So next, when you look at option A, it says to prove that sin 2x plus cos 2x minus 1 is equal to this. So we have two choices. How do we do it? We can either solve the equation on the left and make it equal to the right, or solve the equation on the right and make it equal to the left. But first, when we look at the entire equation, we see that all the angles are 2x, so I need to make it x. Do I have to turn ex into x? Do I have to make it like this? So the formula we use at that time is now called the double angle identity, right? And now, in order to show the process of how this becomes x in the double angle identity ex, we know how to simplify it, right? So if we start with sine ex, there's only one way to fix it, right? 2 times sine x times cosine x, that's all there is. But then after that, cos is something we need to think about. Cos is either 2 to the power of cos minus 1, or 1 minus 2 times sin squared, or cos squared minus sin squared. You guys have to decide and choose one of these three options each time. What should we choose? We might hesitate and think about it, but since there's a minus 1 at the end, I feel like we should go with the second option. So, since 1 gets cancelled out like this, let's start by removing 1 and see. Of course, it could be different, but since there's a minus 1 after the subtraction, let's try fixing it like this. Instead of cos 2x, let's change it to 1 minus 2 sin 2x. And when we write the minus 1 at the end, we see that the minus 1 and 1 cancel out, and what's left is 2 sin. It comes out on the right, right? So these remaining terms, we remove the 1. 1, I erased it and combined it with sin in 2. So it will be cos in the front and sin in the back. So I proved A, and of course, I think we should use this to solve the next problem. We have to solve the second trigonometric equation, even if we didn't do A. When we see a trigonometric equation like this, the first thing we need to do is to unify the angles. Right, huh? First, unify the angles and then do something. If you see x and x, of course, think you need to use the angle formula here, right? Handled that already from above. They want me to fix this. Obviously, same thing here. So let's fix this part like this. I'll fix this part with this. 2 sin multiplied by cos sin, huh? Seems like they're grouping it with cos sin, right? That's right. Whenever you factorize an equation, you group it with cos sin. When I grouped it with cos sin, I got 2 sin in the front and plus 1 in the back. Now I grouped this, and after grouping, I have 2 sin in the front and plus 1 in the back. Multiply to get 0. So either the left is 0, or the right is 0, or both are 0, or this is 0, or cosine minus sine is 0, or 2 sine plus 1 is 0, or cosine and sine are the same. Or we always divide this shape by cosine and make tangent. Tangent is 1, or divide both sides by cosine. Cosine can be 0, then we can't divide. This shape doesn't make sense if cosine is always 0. Right? Because here we're dividing by cosine, and you can't just divide by cosine without caution because cosine can be 0. But why can we divide this? If cosine is 0, then sine should also be 0. But it's never the case that both cosine and sine are 0 at the same time. So we always divide this shape by cosine and create tangent to solve it. Is tangent 1? Where is tan equal to 1? Considering the range of these positions, it appears to be from 0 to 2p. Now, we're discussing what we see on the circle. The tangent is 1, so you know that this is 1/4 pi and this is 1/5 pi, right? So sin plus 1 equals sine 0, which means sin equals sine 1/2. Just like sin equals sine 1/2, we can find it here and here. So if we say it's 6/7p and 6/11p, then we have 4 solutions for the equation we need to solve.